Good morning and salam sejahtera. So, my name is Haikal. My metric number is F1124. Today we will do a discussion about application in differentiation.
So for our group, we got the question two. I will do the A question. The question is f x equals to x squared plus 3x plus 4. So for the first thing we're gonna do is we're gonna differentiate the equation. So fx equals to x squared plus 3x plus 4. We will differentiate it and get the answer is 2x plus 3. And with this answer, we're gonna find x. So fx equals to 0 and 0 equals to 2x plus 3. The 3 go over here and it becomes negative 3 equals to 2x. We're gonna find x, so 2 we will transfer it here, become a negative 2 over negative 3 over negative 2. So the answer for the x is x equals to negative 3 over 2. So let's move to the next step. We're gonna substitute the answer to the equations. So we got the negative 3 over 2. Fill it into the equation. We got this type of equations. And you can press the calculator to get the answer y equals to 7 over 4. That's all from me. Thank you.
Okay, now I will continue. Next step, next step is we need to find a nature. Why we need to find a nature? Because we want to know how our graph supposed to look like. Okay. Kita mau tahu kita punya graph minimum atau maximum. Okay, first we get this from this just tulis balik. Okay, dia punya jalan kerja ni macam begini je. Okay, the important things here. So if our value is more than 0, it means our graph is minimum. So if our value is less than 0, it means our graph will be a maximum. So I will show you the example of minimum graph. So this is example of the minimum graph. So you can look here. It look like a happy smile. And I will give you the example of the maximum graph. Yeah. Just an example, yeah. Okay, this maximum graph punya bentuk lah. Okay, tengok nampak sedih. Itu je kalau dari saya. Okay.
Okay, now the question B is y equals 4x cubed plus 3x squared minus 6x. First step usually is find stationary point using first order directive. It's dy over dx. Now we insert this question and we'll get this answer. Now we change dy over dx to 0 and this answer we insert this and use this calculator to using equation and get x1 and x2. Now we use this equation and change x 1 over 2. This x we change all and the answer we get is minus 7 over 4. And x2, we do the same thing like we change x all to -1. And the answer we'll get is y equals 5. So, stationary point we get in x1 and x2 is -7 over 4 and 1 over 2. And x2 pula is 5 and negative -1.
So to find the nature, we're using the second derivative differentiation. So the first derivative equation, to differentiate again, we get 24x plus 6. 6, the x is 1 over 2 and -1. So we substitute the x into the equation, we get the 18. So 18 is a positive number and larger than 0. So the maximum point for this x1 is minimum point, which is like this. So smile. So next is when we substitute the -1 into this equation, we get the -18, which is the negative value. So negative value is less than 0. So if we get less than 0, so we get the maximum point. So the graph will be like this, the more one. So this is the graph. This graph we call cubic graph. So cubic graph. So okay, this is the root, which is the x1 and the y1. Okay, this is the point, minimum point. This is the maximum point, and then this is the root. So this is the full equation. Why we call this cubic graph? Because we have the cube here.
Application of differentiation in engineering field. The example differentiation that can be used in engineering field is automotive mechanical field. For example, they need to find the velocity of the F1 car, so differentiate the displacement over time, ds over dt, to find the velocity of the F1 car. Differentiation used not to be a pro F1 player, but finding a changing speed to make more power.